Hello! It's been a while since I last checked in on this project, and I apologize for making those curious wait so long for the final video. But now is better than ever, so here I am. The first two videos in this series outlined the general project and technical theory, and in this video I will go through a quick review of the implementation process as well as provide a demo of the code in action, so you can see it all doing its thing. So let's get started. For this implementation, I chose to use TensorFlow and Keras. My reasoning behind choosing those over other libraries is that this combination worked really well and was fairly simple. At this point, these methods and techniques are probably outdated, but all I know is that TensorFlow is simple to use, and as a beginner in the world of AI and machine learning, it was great to work with. So, let's take a look at the code. In classic computer science fashion, the relatively abstract and long explanation of theory from the previous video can be condensed down to less than 10 lines of code. So thinking back to the theory, we have the three standard layers. We have the patch extraction, the nonlinear mapping, and the reconstruction layers. So if you don't necessarily remember what those layers mean, I highly recommend checking out my second video. I go in depth about kind of what those are in theory, and I won't really cover that now because the previous video covered it. I completely forgot to explain what all these numbers mean and why I chose them. So I'll briefly just go over that for anybody who's curious. And it actually just comes from the paper, because the scientists who wrote this paper, the paper that this whole project is kind of based on, already did a lot of analysis and figured out what parameters kind of were best. And you can see in the paper, which there's going to be a link to in the description, they did a lot of different tests with what size filters to use, what size kernels to use, and so I didn't really do any experimentation to figure that out. I just copied what they did. I basically took what they theorized in the paper and what they also probably wrote the code with and just put those numbers in. But yeah, that's it. This is the implementation of srCNN. So thanks for watching, and I will see you next time. I'm just kidding, obviously. I built a demo to go along with the code so that I can show you what the model actually produces, because it's no fun just to look at code and not see what it does. There will be a link to the demo in the description if you'd like to check it out. No guarantee that it works well, because I threw it together fairly quickly last spring. There's a lot of room for improvement, let me just tell you that. Anyways, none of that is relevant to me showing you the stuff working, so let's get into it. I'm going to do a full walkthrough in a second, but first I wanted to discuss the data sets. So I contemplated for a while whether I should use an existing set or somehow build my own, and I tried to mess around with the div2k dataset, but it turned out to be overly complicated to use, at least for me, and the reference images didn't match the style that I was looking for or kind of what I was envisioning for this project. So instead, I designed my own using Pixum. You'll get a better idea of how this works when I run the demo, but basically the dataset is created by fetching n random images of a certain size through Pixum via HTTPS. A random pixelation filter is then applied to each image to create a high resolution and low resolution pair. And then once you get all of your data, it's kind of like split into validation and then training data. So again, like I said, you'll get a better idea of this when I run the demo, but I just wanted to give a little bit of background. The code for the dataset creation and pixelation isn't necessarily important to see, but I just thought maybe you'd be curious. So that's it. Nothing too special. I just found that it was easier for me to make my own data rather than try to use what's already out there. And it was also a little pretty fun to try and figure out how to do this. With that being said, I'm going to show you a full run of the demo and just give you an idea of what the process of setting up the training scheme is like, the various options you have for customization, and how the dataset looks, as well as what the model produces and various metrics of performance. Just a quick disclaimer, while this demo does make this whole concept more accessible, it is far from perfect. I've identified at least one major flaw, which is that if multiple people are using the demo simultaneously, they will overwrite each other's session data, which is a whole big mess I didn't want to figure out how to fix right now. Let's just hope that only one person is curious at a time. Just kidding. Just keep that in mind. If you're using this demo and it doesn't work, it's most definitely with 100% certainty, most likely probably my fault. Let's get into this demo. So I built this demo using Streamlit, which is a really convenient way to build a website with Python and just various code widgets and stuff to portray ideas, which is perfect. So here it is. It's got a bunch of different options on the side for customization, so we can choose what size images we want to test on. So they're going to be square. That's just easy. The number of training samples, the number of validation samples, the number of epochs for training, the batch size for, well, batched training. You can pick the optimizer that you use for training in the models, as well as the loss function, mean squared error, SSIM. We'll get into that, which is actually in the previous video we talked about that. And then there's, this generate dataset, train model, and then all this testing stuff. But we'll get into that in a second. And then you've got the output log, the model performance, which will show like graphs based on the model's performance, the test output, the output of the model based on a test image that you input, and then you can see your data set. So let me just refresh session. Yeah, there's no data set yet. So let's go ahead and get into this. So let's say we want to do image sizes of 256, and the number of training samples will go, well, we did 80, 20, so let's do 160 and 40 validation samples. Epochs we'll do, let's just do 10 for the purposes of this video, and we'll keep the atom optimizer and mean squared error. Actually, I'm going to switch it to SSIM. So if you remember from the previous video, SSIM is the quality metric to calculate loss or accuracy. And then we are going to, so as per the description here, choose the parameters in the sidebar and then click to generate dataset. So we're going to generate the dataset. We see here it's downloading the dataset and creating it as we speak. And because there's a lot of images, it's going to take a while, but you can see here the progress bar is progressing. So I will jump back to this when we are fully loaded and I can show you the dataset. Okay, so the dataset just finished being created. So we can head over here to the preview dataset page, and we can select, okay, well, let's look at the training data, and we're going to look at the high resolution images right now. So if we go through here, we see all these random images that were pulled from Pixel. If we want to look at the low resolution copies of those same images, you see, okay, well, let's compare it to the previous one. High resolution, all these blah, 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 blah. And then you go here, low resolution. This just gives you a better idea about how I created the datasets. Now I know this is hyper specific to my case scenario where I just wanted to create a model to kind of repixelate a picture of my dog that I really liked. So all of this entire project is hyper focused on that one train of thought. So a lot of this is not practical and scalable on a large thing, but it's more experimental. So that's kind of what's going on here. But anyways, so yeah, now that we have the training set, we can go ahead and train the model, which is again going to probably take a while. So yeah, let's go ahead and train the model. Creating model, preparing data sets, and training. The model is now trained fully. We've got our performance here, which is pretty cool, some graphs. So we've got the validation and training loss. So you can see it kind of goes down and kind of plateaus. And then the validation to track, the accuracy kind of goes up and plateaus a little bit. It's kind of wonky. Now this would be better with bigger training sizes, more epochs, but honestly, I've tried it with bigger numbers on this computer and it crashes. So, but anyways, that's the exciting part is now to see what the test output is. And to do that, we've got to press the test output model. But I'm just going to use the default image. Let's see what it does. Let me zoom in a little bit here. So here we are. This is the one that the model produced. This is the one that we put in the model, and this is what we're trying to recreate. So if you see this, oh yeah, you can tell it's a dog, blah, 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 but it's got all these pixely goopiness. And then you go over here, it's blurry, it's low resolution, but it's not pixelated, and it's much more representative of my dog's nose than the middle one. So there's the model. That's a demo of it. I hope you enjoyed. You're welcome to mess around with the demo on your own, put in some test images that you want to see. But yeah, that is the SRCNN demo. That's it. From project idea to implementation, it took a lot longer than I had planned for this to be done, but I'm glad I did it. I learned a lot along the way, and if I'm being completely honest, I also forgot a lot along the way because it's basically been 2 years since the previous video. So if this seems a little bit wombly jombly and it's I don't know what I'm talking about, Not only is it because I didn't really know what I was talking about to begin with, but also there's a 2-year gap between when I really was fully putting a lot of time into understanding this to now. So here we are. Anyways, I look forward to more projects like this in the future. I can't wait to hear what you think. Please feel free to leave a comment with any questions, suggestions, or anything of the sort. I hope you found this mini series interesting, and I hope you have a wonderful day. Don't forget to check out the GitHub repo for the online demo and the other videos. There will be links in the description. But yeah, hope you enjoyed. Thanks for sticking around, and I will see you in the next project video.